Hey guys, so real quick, I just wanted to make a short video on chi-square analysis. So I covered this in class, so this isn't going to be in depth. This is just going to be quick review for anybody who might have missed that day and or who wants to review what I went over in class. Okay, so chi-square analysis is a statistical tool used to answer the question, is something random? Right? Is this particular data set random? Or is something driving the findings? Um, so our equation is that chi-square equals the sum of the observed minus the expected squared over the expected. And so an example of this, if I'm going to flip a coin, and I wanted to determine if the outcome of those coin flips are generated by the random probability of the coin flip, or if there's something else at hand, okay, I can do this chi-square analysis. So my expected is derived from the math of probability, right? So I have two options, they're equally likely. So I expect a 50-50 distribution, right? 50%, 50%. So if I have 100 flips, okay, I would expect to see that 50 of those flips result in heads and 50 of those flips result in tails. Okay? Now we know from real life that that's not how it actually pans out most of the time. Usually it's gonna be like 48-52, right? 47-53, but in that range, right? There's a random variability to it just by the nature of probability. Okay? Now, if I would actually do this flipping experiment and I flip the coins and I observe them through experimentation to show that 40 of those coins resulted in heads and 60 of those flips resulted in tails. The question is that random or is something changing the way that this coin flips, right? Is there some reason why I got more tails than heads other than random probability? Okay. So that's what chi-square analysis is doing. So I got my equations set up here. Okay, so my heads. I observed that I got 40 heads. Okay, minus the 50 that I expected through math squared. Okay, so 40 minus 50 is negative 10. Okay, and then it's over the expected, okay, 50. So I have negative 10 squared over 50. I have 100 over 50. I have 2. So my value for this particular equation is 2. Okay, I do the same for my tails. Okay, I got 60 minus 50 is 10 squared over my expected. Okay, gives me again 100 over 50, which gives me 2. I must sum these up. Okay, and so the sum of all my values is going to be 4. So that's my chi-square value, is 4. To actually make use of the chi-square value, I need to use a p-chart. Right? So p-value is telling us whether or not findings are significant. Yeah, and so you need a chart to do this, right? But first you need to know your degrees of freedom. Okay? And your degrees of freedom is really easily determined. It's just the number of options you had minus 1. So for the coin flip, I had heads or tails. That's 2 options, right? So 2 options minus 1 equals 1 is my degree of freedom. Okay? So I got my make-believe p-chart here, right? In real life, you'd look one up and it'd be prettier than this, but this is how it's set up. You have your degrees of freedom on this side, your y-axis. Your x is going to be your p-value, and then inside the chart are your chi-squared values. Right? And so I'm going to my degree of freedom of 1 because I determined that my degrees of freedom was 1. And I'm going to scroll through until I find where 4 would be placed. Right? So I got 11, I got 7, I got 3. So I know that 4 is in between 7 and 3. Okay? So it's going to be right about here. I'm going to drag that up. And so I know that my p-value is somewhere between 0.05 and 0.005. Okay? So I know that somewhere my p-value is. I don't need a precise number. Okay? It just gives me that somewhere in between those two things. Okay? Now, the importance of the p-value is if your p-value is less than 0.05, your findings are not random. They are considered significant. Right? So something is happening that's causing your data to be the way it is. Okay? If the value is above 0.05, then the findings are random. Okay? It's not a significant finding. It just happened by random chance. Okay? Now, this is a typical number of significance for most science. Medical science typically requires a little bit more strict findings, and so it can be 0.005. Some even require 0.001. Right? And basically, this value is just saying if I did an experiment 100 times, right, 95 out of those 100 times, I would get the same results. And then 5 times, something would be messed up. Right? Either it was caused by human error or bad calculation in the machine. Right? Something ruined the results and they're not real. Okay, so the 95 results are real. Okay? If I have, like, a higher number, 0.5, that would mean that 50% of the time the results were messed up and the other 50% were maybe random, right? And so, like, that's not good. Like, if half the time I get the results the same, that means that the findings aren't good, right? Not significant. Okay. Anyways, for chi-square, again, here we got this. Okay. If p is less than 0.05, it's not random. And if it's greater than 0.05, it is random. Okay. So something's causing it in the coin flips, right? That could be that my coin isn't evenly weighted. Maybe the heads weighs more than the tails. Okay. That's it. Chi-square done. Bye.